All right, folks, welcome back to our last section in the Prob and Stats chapter. Okay, our last statistics section, 1.7, scatter plots. So as you can see, we're talking about scatter plots today. Here we go. Start off with some definitions. Okay, first off, scatter plot, that's going to be a graph that relates two sets of data. Okay, so far this chapter we've only looked at one variable statistics. Okay, where each observation we just get one number for it. Okay, scatter plots, each observation we're going to use two numbers for it. Okay, so we have some examples of scatter plots down here. We can think of the first one here as the number of hours you study per week compared to your GPA. Okay, we can look at relationship as you study, as that goes up. Okay, how does that affect your GPA? And how we can describe that relationship is going to be with what's called the correlation. I'm going to say that's the strength of the relationship between the data sets. Okay, so we can think of hours studied per week in GPA as having a strong positive correlation. Okay, the more you study, the higher your GPA should be. Okay, we could also talk about a weak positive correlation. This would be two things that aren't as strongly related. So maybe it's hours of sleep per week and your GPA. Okay, not as strongly related as hours studying, but still related. Okay, now if there's no pattern to our data, we'd say it has no correlation. So for example, this could be your height and GPA. Okay, really doesn't matter. They really don't affect each other. And we could also have data with negative correlations, both weak and strong. So for example, the hours you brush your teeth per week and the number of cavities you get. Okay, as brushing your teeth goes up, we'd expect cavities go down. That would be an example of a negative correlation. So let's take a look at some questions we can answer using scatter plots. Okay, problem 1 says the table shows the relationship between states, populations, and the number of drivers in the state. Okay, so we have a table with populations in millions and drivers in millions. Okay, it'd be nice to compare the two because we'd expect the more people in the state, the more drivers we'd also have. Okay, part A says just sketch a scatter plot for the data. Okay, we'll do a rough sketch here. We don't need to break out any graph paper or anything like that. Okay, typically with a scatter plot, you're going to think of your independent variable as your x variable. Okay, I'm going to think of my drivers depending on population, so I'll put the pop on the bottom. Okay, drivers on the y-axis. And then it looks like here we can just count off by 5 millions at a time, so we can go 5, 10, 15, 20, and 25. Again, just making a rough sketch here. We'll cut off by 5s for the drivers as well. So 5, 10, and I believe 15 will be all we need. Yep. And then what we'll do is just plot that data. Okay, when I have a population of 2.8, I have drivers of 2. So we'd say here's about 2.8, here's about 2, and plot a point. Okay, we'll do one for the 12.8 and the 8, be about there. Again, this is just a really rough sketch. I've got another 2.8 and a 2.1, so we'll put those on top of each other. Okay, 6.4 and a 4.7. All right, 12.4 and a 8.5. Okay, these aren't lining up great, but I'm just looking for a rough sketch here, so it's good enough. 23.5 and a 14.9. Okay, 10.1 and a 4. I'm sorry, 10.1 and a 7.3. That looks a little bit better. And then a 4, 2.9. Okay, we'll say it looks something like that. Okay, again, doesn't need to be perfect. We just want a quick way to visualize this. And yes, as we expected, the more the drivers go up, the more the population goes up, the more the drivers go up in that state as well. All right, part B asks us to describe the direction and strength of the distribution. In other words, describe its correlation. Okay, it looks like things are correlated. Okay, it looks like there's a pretty clear pattern. As my population goes up, the drivers go up as well. So it's definitely positive. I'd say this is a strong positive correlation. Okay, because things mostly fall in a straight line, things mostly match up here. Part C asks for the equation of a least square regression line. Okay, we could also call that a line of best fit. In other words, we want to figure out what's the equation of a line that matches this data here. Okay, to do that, we're going to pull up the calculator. And first thing I'm going to need to do is put these different values into my table. So for that, we'll go Stat, Edit. I'm going to scroll up and hit Clear, Enter to clear out my Table 1. And then for my List 1, what I'm going to do is I'm just going to put all these values in for my my populations. So we have a 2.8, Enter, 12.8, Enter. Okay, so I'll get those in. And then I'm going to scroll one to the right for my list 2. And now in the same order, I'm going to put in my values for the drivers. And it's important to get these in the same order here so they match up. So then once we have those values in, we're going to let the calculator do the work, okay, for the regression line. I'm going to hit Stat again. Now that I have my list edited, I'm going to scroll over one to the right for Calc. And then the option I'm looking for here for the least square regression line, we could also call it a linear regression line. So we'll do this lin reg. Hit Enter. Okay, we want this graph for the X list with the list 1. Okay, that's where we put what was on the X-axis, the state populations. So we can say Enter. Y list, that's our list 2. Okay, that was the drivers. Hit Enter. Okay, for the rest of the stuff, we can just hit Enter until we get down to Calculate. And then what it's going to do is it's going to give us an equation of the form y equals ax plus b. Okay, where my a and b values are given to me as these big ugly numbers here. Alright, so we can write out that equation. We can say our least square regression line is y equals 0.620, okay, for the 99x. Okay, so there's my a value, alright, plus a 0.516 for the b value. Okay, that's my least square regression line. That's going to be the equation of this line we kind of approximated here. All right, then the last part of this question, and the whole point of having a regression line, is to make some predictions. So part D says, if Minnesota has a population of 5.5 million, how many drivers would you expect to have? Okay, so what I can do is I can use my least square equation, and I can plug the 5.5 million in for the x, because we know the population is our x value. Okay, so we can say y is equal to a 0.620 times 5.5 for the x, okay, plus a 0.516. Okay, now notice I did use 3 decimal places for this a and b value. Okay, that's going to keep things just more accurate than if I used less. Okay, when I plug that in, I end up with a 3.926. In other words, 3.9 million. Okay, and if we plot that point, okay, let's see here, 5.5, okay, about a 3.9. Yep, looks like that's going to fall along with our scatter plot, so that makes sense. Alright, so that's how scatter plots work and can be used kind of in the calculator to make predictions. Problem 2 is another situation where we can make a scatter plot. Why don't you take a few minutes here, pause the video, work your way through that example, and then hit play to check answers. Alright, let's go through the answers here quickly. Problem 2, we have the relationship between video gaming hours per week and GPA. Okay, sketch a scatter plot for the data. Again, we'd expect the hours of gaming you do a week, okay, to kind of relate to kind of determine what your GPA is going to be. And then we have our rough sketch here. In part B, we'll describe the correlation. Okay, so we'll describe the direction and strength of the distribution. Okay, I'd see pretty clearly that as the hours of video gaming per week goes up, your GPA is going to go down. Okay, as far as you gamers go, we'll say it's a weak negative correlation. Because it's not quite in a straight line. Okay, it's not, grouped directly along a line. Okay, but it is a negative correlation. Okay, the more you game, probably the worse your grades are going to be. For part C, we want to use our calculator to find the equation of the least square regression line. Okay, I pull my calculator up. I already have the gaming hours in list 1, the GPA in list 2, and again, to calculate that, we'll go stat, scroll over to calculate, option 4 for linear regression. Okay, we want the X list to be L1, Y list to be L2, and calculate. And it gives me an equation of the form y equals ax plus b, okay, where the a is a negative 0.087. We'll round to 3 decimal places, and the b is a 3.833. Okay, so that's where this equation is coming from here. And then last question, if a student played 15 hours of video games per week, what do you expect their GPA to be? Okay, so when x is 15, we can plug that into our least squared regression equation. Okay, so here's my x. Just plug that in the calculator. We get a y equals 2.5. Okay, so we'd expect a GPA of 2.5. All right, there you go. Scatter plots, pretty simple. Give the homework a shot. Rewatch the video if you get stuck somewhere, and we'll see you later.